you one. Oh, it says I'm recording. Oh, no, you're recording. Hi, everybody. Okay. We are going to go ahead and have a fun day of math. So get out your math spiral and your math workbook and a pencil, and we will get started right away. Thank you for coming to class prepared. So today you will find your assignment again under math. Today is Wednesday. We are doing lesson 3.14. This is our last lesson in this unit. That sure was a long lesson.
Robin,
Yeah.
so you know how you thought I wasn't there
I can't hear you, honey. You're muted.
you know how you thought I wasn't there at all, Block? I actually was there the whole time.
Yeah, but I had to let you in later, like you were gone, and then I admitted you in again.
Yeah, cause I tried to leave and come back in, so to try to fix it, because I thought something was wrong with my Chromebook.
Okay, let's get started. Today we are going to solve word problems using data in line plots and scaled bar graphs. So we're going to use everything we've learned and then use our problem solving skills to help us. Just because there are a lot of problems in real life that involve bar graphs and line plots. That's a great way for people to share information and for us to gain information. So we'll be looking at 1 and 2-step word problems using the data from the scaled bar graphs and from the line plots. There you got it. Let's go ahead and review. I keep saying this week because I want to make sure when you come across a problem you might not know the answer to and you can't remember those strategies that we've talked about, that you will go back and draw a picture. So today I'm going to ask you to hold up your spirals again like we did yesterday. I want us to, even if we know what 4 times 8 is, I want us all to draw this picture. You ready? We're going to do it. What would I draw if I wanted to find the product of 4 times 8? Jensen, what would I draw? Think about what we've done the past few days in math for our review.
So, we should draw like an up and down equation.
What have we been drawing? And I've been putting dots inside of them or tally marks inside of them. What is that shape called? Looks like a clock. A circle. We're going to draw circles. How many circles would I need, Jensen? 4 groups of 8. What would that, how many circles would that be then?
So,
What's the first factor? How about that?
so 8.
That's the second factor. What's the first factor?
1.
The problem's 4 times 8. There's only 2 factors. What are the factors, Jensen? What 2 numbers are we multiplying? What's the first problem on our screen, Jensen? Can you read it for me?
4 times 8.
4 times 8. Is there a 1 in that problem?
No.
No 1. What's the first number you just said? That's our first factor. Remember, factors are numbers we multiply, and the product is your answer. What's the first factor, Jensen?
4.
4. So how many circles are we going to draw if we have 4 groups?
So we're gonna draw 4 circles and put 8 mini circles inside of them.
Yep, or you could do dots or you could do tally marks. So let's all do it. Let's draw our 4 groups of 8. So you would draw 1, 2, 3, 4. I want to know what 4 times 8 equals. That's the same thing as saying 4 groups of 8. Remember, it's repeated addition. 8 plus 8 plus 8 plus 8. I'm going to draw a picture to make sure I get this right. 1, 2, 3, 4, 5, 6, 7, 8. I want you to do this too, just to help you remember the strategy. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Now I want you to count those and tell me what 4 groups of 8 equals, or 4 times 8 equals, or 8 plus 8 plus 8 plus 8 equals. They're synonymous. They're the same thing.
32.
Instead of saying it out loud, you're going to write it in your math spiral and raise your hand, because we want to make sure people get thinking time and we don't want to steal people's learning. Okay, so we're going to keep our microphone muted until we are called on. Thank you. When you think you know the answer, you've counted all your tally marks. Give me a thumbs up. A thumbs up. Ellie Combs, can you unmute and share your thinking with us?
4 times 8 equals 32.
Can you prove that? How do you know?
Because 4 groups of 8 equals 32, because I counted all the tallies in the circles.
And that's what you got?
Mm-hmm.
All right, let's double check her work. Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. Excellent. So if you come across a multiplication problem, and you might do this today in math, you can always draw a picture. Yes, it is time consuming. That's why we want you to memorize these facts. But you can always find the answer if you don't have it memorized yet. By the time you leave 3rd grade, you should not be drawing pictures anymore. You should have them memorized. So we have half of our school year left to get these memorized. Did anyone think of another way you could solve it besides drawing a picture? If I wanted to know what 4 times 8 is, what could I do? Serene.
What I didn't really draw it, but you could, if you know what 6 plus, if you know what 8 plus 8 is, which is 16, you can add 8 plus 8 2 times, and then add 16 plus 16, which equals 32.
That's a great strategy. Thank you for sharing that. So if you didn't understand what she said, she did 8 plus 8 is 16, 8 plus 8 is 16, and 16 plus 16 is 32. And you might have to stack that, right, to make sure you get the right answer. Marin, I see you have your hand up.
How I did it was if you know what 5 times 8 is, it's 40. Then you take away 8 from 40.
And why does that work?
Because you count on your fingers 8, and you get the answer, which is 32.
Excellent. If we know 5 groups of 8 is 40, isn't 4 groups of 8 1 group of 8 less than that? Yeah, right, because 4 is 1 less than 5. Excellent. All right. That's a lot of different strategies that you guys can do today. Looking at the next problem, 3 times 8. If we know 4 times 8 is 32, what do you think? We know 4 times 8 is 32. What would 3 times 8 equal? Max Giesberg. The same as saying 8 plus 8 plus 8, right? 3 groups of 8.
There's no peas. You sliced it? Yep, my nail.
Max, you're muted. Max Giesberg, just so you know. Finn, you want to help him out?
3, 8 plus 8 equals 24.
Okay, how do you know?
Because you can either count, I counted 8 3 times, or you could count to threes 8 times.
Yeah, you could use the commutative property, couldn't you? And then you could count. Could you draw a picture? Max Fox, could I draw a picture? Can't hear you, bud. I don't know if it's your volume, but yep, you could. 3 circles with 8 in each, like we did before, right? And then we could count them up. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. And we get the same answer. All right. 42 divided by 7. I'm going to show you how to draw a picture to figure this one out. I want to know how many 7s are in 42. So I'm going to take that 7 actually and draw 7 circles, just like we did for the multiplication. 1, 2, 3, 4, 5, 6, 7. And I'm going to divide 42 of these dots into my circles. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42. Then when I go back and I see how many are in each circle, I see that there's 6 in each one. So how many 7s are in 42? 6, or 6 times 7 equals 42. I could also use that inverse operation. Now, this time we have 18 divided by 6. Who can explain how to solve that problem? 18 divided by 6. How about Robert? And Robert, remember, no food during our Zoom time.
Sorry, okay. 18 divided by 6 is, 18 divided by 6 is 3.
How do you know? Can you prove it?
Because I tried to remember, I remembered what 3 times 6, what times 6 was.
Okay, so you use the inverse operation. So you thought what times 6 equals 18?
Yeah.
Okay, we could also use a variable, right? Maybe we say A times 6 equals 18. We want to know what A equals. And you say A equals 3, or the answer is 3, because 3 groups of 6 equals 18. Did anyone get something different? Or not different answer, but Finn, how did you solve that? Oh, Lila Morris, can I have whole body listening, guys? Let me do a quick reminder, Finn, for you too. Ears are listening, mouth is quiet, hands and feet are down and still, brain is thinking about what is being said, and eyes are looking up here. So we don't have any balloons in our hand, right? We're not playing with anything. Finn, how else can you do that besides using inverse operation? How can you find 18 divided by 6? You're muted, bud.
You can count up 6 until you get 18.
Will you do that for us? Show us how you do that.
6 plus 6 equals 12. And if 2 6s make that high of a number, you can't add two more 6s to make, because 12 plus 12 doesn't equal 18. So 3 6s equals 18. So it equals 3.
Excellent. So you could just count 6, 12, 18. Nicely done. Ellie, can you get rid of it, please? Thank you. All right, let's move on. Ellie, will you do this one? 428 plus 244. Walk us through that, Miss Holmes.
So 8 plus 4 equals 12. So you put the 2 under the 4.
Okay.
And you carry the 1 above the 2. And then 3 plus 4 is 7.
Mm-hmm.
And then 4 plus 2 is 6.
Excellent. We're going to skip the next one due to time. So I'm going to jump right on over to 842 minus 365. Let's see, Lila Fitz, would you be willing to walk me through this one? Bird?
So, 2 divided by 5 is 3.
Okay, but then can I take 5 away from 2? It's smaller than
No. So, yeah. That
oh boy.
to go over to the front ball, 2 into 12, and then you turn the into 3. Divide 7.
12 minus 5 is 7. Okay.
And then you have to go over to the 8 and borrow from that. And 2. And 8 into 7, and then
All right, I'm trying to help you out, Bird, because you have a bad connection. I think this is what you were telling me.
Miss Aubin, can I do the next one, please?
Sure.
yeah, and then 13 subtract. Wait. No. 5. 5. 7.
All right. Haley, was that you? Thank you, Bird. Good job. I'm sorry we can't hear you. We're going to move on to the next one, 900 minus 745. Go ahead, Haley Bucher.
So the first what you have to do is take is 0 minus 5. So you can't do that. So you're gonna have to box the 90 and make it a 85, and then make the 0 into a 10, and then 10 take away 5 is 5. And then 9 take away 4 is 5, 2. And then 8 take away 7 is 1. So the answer is 155.
Okay, let me just clarify. You make it 89, not 85, because you only need to take 1 away from it. Just, I think you meant that, but said the wrong one. Okie dokie, just want to clarify. All right, looking at our clock, Max Fox, what time is it on our first clock here? Let's start with the hour hand. What's the shorthand pointing to?
The 10. And the second, and the other one, if you go to the one, that's 5. And then the 2, it's not quite on the 2. It looks like one below. So I think it's 9. I think it is 10:09.
Excellent. If it is 10:09, and I am with Mrs. Harrison in EL, Max, is it AM or PM?
AM.
Yes, good job. All right, the next clock. Let's have Lila Morris. What time is it?
On that clock, it's so if you look at the hour hand, it's between the 3 and the 4, so it's 3 in the hour. And then if you look where the minute hand is, it's before the 7. And I know that the 6 is 30 and the 7 is 35. So if I go back 1, it's 34. So it's 3:34.
Excellent. And if we are just finishing up school and the bell's about to ring, is it AM or PM?
PM.
Very good. PM. Boy, you guys are getting good at that. What unit is better to measure the length of a finger? Centimeters or meters? Stand up if you think centimeters. Stand up if you think you should use a big meter stick to measure the length of your finger. Oh, I hope nobody's standing for meters. Think about it. A centimeter is about the width of your fingernail, right? A meter stick is about 3 inches longer than a yardstick. So it's about this big, right? A little over 3 feet. So you definitely want to use what, August? Centimeters or meters to measure the length of your finger?
Centimeters.
Very good. You want a smaller unit if you're measuring the length of something that's not very long. All right. Hold up your math for me. Let's see how we did. Everybody hold up your math spiral. Show me your work. Let's see how you did. Thank you, Elena. Good job, Leo. That makes me so proud. You are going to need to use that math spiral during Think Central. You need to use that during GimKit. You need to use it during map testing tomorrow, or not really the spiral, but a scratch piece of paper to show your work, show your thinking. That's how you improve. Lennox, can you put it in front of me instead?
Yes, I'm needing a lot more of them up, my friends.
Just want to see how we're doing with our review.
Yep, I'm looking for more notebooks, my friends. Everybody should have their spiral up to their camera.
Thanks, Astria. So if you're not showing me, I'm guessing you didn't write it down, and I want to encourage you to do this work. Again, I don't need it. I need you to do it so that you get the feel of it, the writing of it, the practice. Ellie, that's awesome. Thank you. All right, kiddos, you can put them down. Let's move on to our learning target with problem solving using data. I believe we are ready. We're going to need our math workbooks today as well. Don't get rid of that spiral. We're going to use that too. We haven't seen this image in a while. This is our reminder of when we are solving word problems, we want to read carefully. Remember to visualize what's happening. You don't just want to pull numbers out of a story problem and say, oh, I think I'll add these together. No, you got to understand. It's just like comprehending what you're reading in EL or in science, the same idea. We're going to look for clues, model the relationship, find the unknown, and then reflect and see if it makes sense. All right, we're going to look at page 205. Here's the data in our bar graph. And I think somebody got muted. If you can mute for me so there's no feedback, that would be great. Thank you. 5 teams of students are riding their bikes after school to raise money for the computer lab. Every completed mile will earn the computer lab $2. The bar graph below shows the number of miles completed in 1 week. Wow, so every time they complete a mile, the school will get $2 for their computer lab. So I'm retelling this to you. That was part of my problem-solving strategy. I want to make sure I understand what's happening. So I'm going to tell you a little more in my head. I hear that they're raising money, so I'm thinking of a fundraiser. It reminds me of our fundraiser for the school in Africa. So I can kind of connect to this. We raised money for Hat Day, so we could send money for meals to the students in Africa. So this is similar, but their fundraiser is by riding their bikes after school. And if they ride X amount of miles, they get $2 per mile for that week. So that's pretty cool. So let's see, I have the number of miles on the bottom. I'm gonna analyze my data. I see it's counting by 20, so the in-between line must be 10, which is half of 20. I see my days of the week, and now I can answer these questions. So let's think, how much money was earned for the computer lab on Tuesday? Now we gotta be careful. They get $2 for every mile. So we're gonna have to do a little extra thinking here. Use that graph. If you think you know how much money was earned for the computer lab on Tuesday, raise your hand. Astria, what do you think?
I think how much money was raised on Tuesday was $80.
Okay, so I see that you read the graph and you saw that 80 miles were ridden, right? So they rode 80 miles on Tuesday. But then you changed that 80 miles to dollars. It would be $80 if they got $1 per mile. But in the directions, it says that every completed mile will earn the computer lab $2. So let's think about it a little more. Because if I reflect and I say, okay, they rode 80 miles, so they got $80. Well, that would mean they only got $1. That doesn't make sense. So let's rethink that, which is a good thing. Reflecting helps. Anybody have another answer? She's on the right track. She did the first step. Henry, what are you thinking?
I'm thinking 160.
Why do you think $160?
Because 80 times 2, 8 plus 8 is 16, add a 0, and you get 180.
I am so proud of you, Henry, because you knew to multiply, and that makes me so happy. So if you have 80 miles and you get $2 for every mile, we need to multiply it by 2. He just said we take the basic multiplication fact, 2 times 8 is 16, and then add that 0, and you get $160. Wow, I'm really proud of you, Henry. Good job. All right, we're gonna do the same thing with the next problem. We're gonna analyze it. How many fewer miles, I'm gonna circle the keyword fewer, were completed on Monday than on Friday? Now this time, Astria, be careful. We're not talking about dollars. This time we're talking about miles. So do we have to double it? No.
Miss Toppin,
Yes.
I can't see your screen with for 205. I can't see the screen.
Okay, you should have page 205 in front of you.
Uh-huh.
And you can see most of my screen?
Like, I can't see your writing.
Oh,
I can see it.
you want to check that out, Mrs. Harrison?
It's fine. I can see it, my friend.
Okay, it's on there. Rachel. All right, so let's.
I can't see it either.
Yeah, we can't see it.
I can't.
Me either.
I can.
So Gavin, I'm going to ask you to unmute. What should we do to find out how many fewer miles were completed on Monday than on Friday? Not dollars earned, but miles ridden on their bikes. Look at your graph. What do you know about Monday and what do you know about Friday?
Friday has 110 and Monday has 70.
Okay, so if we know that Friday is 110, that's more, right, than 70. How many fewer miles were completed on Monday? What operation does that tell me to use? Addition or subtraction?
Addition.
Okay, so if I add 110 and I add that to 70, I'm going to get 180. Let's reflect. Could that work? Could Monday have 180 less than Friday?
No.
Okay, good. So see how reflecting helps us with our answers? What should we do instead of adding?
Dividing.
Well, we're only adding or subtracting,
Subtracting.
Subtract.
right? We need to subtract fewer. We need to
Find the difference. Somebody needs to mute. If we were dividing, Gavin, we would see something like equal shares or putting into equal groups, or they might even use the word divided,
but we don't see that. So we're not going to divide. So you want to see how many miles Friday has. And we know this is 110 because it's counting by 20s. Half of 20 is 10. And then we know that Monday only has 70. So I would take 110 and I'm going to subtract 70. Go ahead and see if you can figure that out. How many fewer miles were completed on Monday than on Friday? And Gavin, will you walk me through it?
So, you cannot do 0 minus 0, so it'll just
Sure I
be
can.
0.
0 minus 0 is 0. You can do that. That's not a problem. If I have nothing and I give you nothing, I still have nothing. They're the same number. If this number on the bottom were greater than the number on the top, then I would not be able to do it.
Yeah.
Okay, what about 1 minus 7? Can I do that?
No.
So what do I need to do?
Make that a 0 and make the 1 11.
Now what do I do?
Then you subtract 11 from 7.
Actually, you're taking 7 from 11 because you can't do it the other way without getting into negative numbers. All right, so what do we have? What's 7 from 11?
4.
All right. So what's the answer, Gavin?
40.
And what's our unit?
Miles.
Miles. Now let's see if we reflect if that makes sense. How many fewer miles were completed on Monday than on Friday? There were 40 fewer miles completed on Monday than on Friday. That makes sense knowing that Friday had 110 miles and Monday had 70 miles. All right. So number 3, how many miles in all did the students ride? Not how much money did they earn. How many miles in all did the students ride? Lyric. What is the key words there that are going to help me know what operation to use?
The four.
We're on number 3. How many miles in all did the students ride? What do you think we're going to do for that one?
Times.
Jensen, you need to put that away. Okay, I want to know the key word.
How many miles?
So help her out, Josh.
In all.
In all. So Josh, because we have 110 on Friday, 100 miles were ridden on Thursday, 40 miles on Wednesday, Tuesday had 80, and Monday had 70. Can we multiply to find that answer?
I used addition.
Why would we have to add instead of multiply? Lennox, whole body listening. Look at me, bud.
Because if you multiplied 70 times like 110, you would get like a higher number.
Yeah, and it's not repeated addition. It's not equal groups, right? And multiplication is
Higher number
equal.
than ever used.
Okay, so we have to add all of these miles up to find out how many miles they rode all together. So let's do it. You guys do it. I will list the miles, figure out the way that works best for you. Let's see how you do.
I'm going to stack it. You can do it a different way. I'm just going to stack mine up and add them all up like column addition. But I bet some of you are going to use a different strategy. So you can look, this is what we're looking at. All these numbers have to be added together. But you can break them apart, find groups of 10 that you can add together. You can find groups that make 100. Do it however you want. And let's see, we get the same answer.
Miss Alvin, I'm done.
What did you get, Ben?
I got 410 because I added 100. It's kind of complicated. So, the red one was 125, and then the Thursday was 100, and then I added that together, which made 225.
Okay, but I just want to stop you because Friday was 110. This is Friday, this is Thursday, Wednesday, Tuesday, Monday. So you might be off a hair because I think you got the wrong, you said 125. You're super duper 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 close. Anybody else want to share what they got?
150.
Gavin, do you have your answer?
It's 500.
I see a lot of people still thinking. Good job, guys. Way to persevere. This is a tough one.
I'm already done.
I think I know the answer.
What do you think it is?
I think it's 380.
Okay, I hear 380. Did anyone have another answer that's different?
I think it was 400.
I got a 400. Let's solve it in here.
It was 510.
I got a 510. And anyone else? Evie, do you want to share what you got?
Mrs. Aubin?
Yeah.
Mrs. Aubin, I need to go. My mom.
You muted, Evie.
I need to leave the meeting.
Okay, can you watch the video for me?
Mm-hmm.
Okay, thanks, sweetie. Thanks for letting me know. Bye, hon. Okay, so let's check and see which one is right. I'm going to start in my ones place. I'm going to add all those zeros. You should have gotten a 0 in your ones place. I'm going to go to my tens. I have 1 plus 4. 1 plus 4 is 5. Plus 8 more. 8 in my head. Add 5. 9, 10, 11, 12, 13. Plus 7 is going to give me 20. Then I have 2, 3, 4. You should have gotten 400. Jensen, I think that was what you said. So our answer is 400 miles. Now, you didn't have to do it the way I did it. You might have broken it up and said, oh, I see 100 plus 100 is 200. Plus 10 plus 40 is 50. So I have 250. I know 80 plus 70 is 150. And you might have done it that way. I know there's a lot of different strategies.
The real answer was 400.
Okay, somebody's not muted.
It's Ben.
Okay, make sure you mute for me. All right. We're going to stop on this one and we're going to go to the next slide because of time. Let's look at page 206. So move on to page 206. We're going to look at a line plot. So this line plot shows the time to complete 4 laps in minutes. The physical fitness coach asked her students to walk around a track 4 times. 4 laps equal 1 mile. She recorded their times on the line plot below. So we are going to look at the times. Remember, they're in minutes. They go from 0 minutes to 18 minutes. Remember, with the line plot, each dot represents 1. It's not like a pictograph. So the first question says, what is the difference between the greatest and the least amount of time students took to walk 4 laps? Now remember, I told you that the answer to a subtraction problem is called the difference, right? So you know you're going to be doing a subtraction problem. But what are you going to be subtracting? What do you think, Henrik? Look back at the text. Difference tells me to subtract. That's helpful. But I want to know from the greatest and the least amount of what, Henrik?
I don't know.
Okay, what did I circle? Can you see the amount of, do you have the book in front of you? We're looking at the amount of what?
Amount of time.
Time, right? So this is what our line plot is showing us. So what is the greatest amount of time in minutes on our graph, Henrik? What's the greatest?
6.5.
She circled it. She underlined it.
We're looking here on our line. 18 is our greatest amount of minutes. What is that? And it can't be the 0 because nobody got 0. But what did this person run 4 laps in? How many minutes? 13, right? So we want to know the difference between the greatest number of minutes and the least amount of time, right? From 18 to 13. What's the difference between those two numbers you're subtracting? Show me on your fingers when you have that answer. All right. 18 minus 13 is what you are solving. Stack it. Stack it up like we do in our review.
It's 5.
Should have gotten 5. Because if you stack this, if you're not looking at it like horizontally, but if you write it vertically, you're going to do the same thing we do with our multi-digit subtraction. 8 minus 3 is 5. When you get to 1 minus 1, that's 0. We're not going to put a 0 in front of the 5. So the difference is 5 minutes. Then we're going to do one more, then we're going to play Gimkit. So stay tuned here. All right, the last problem is this. More students complete the laps in 16 minutes or more, or in 15 and a half minutes or fewer. We did a problem like this week. We have to look at our line plot, look at your 16 minutes, look at your 15 and a half minutes. Remember, 15 and a half minutes or fewer is all of these people. 16 minutes or more are all of these people. So go ahead and circle those. Tell me which one is more. Is this time have more people, or does this time have more people? If we were analyzing our class and this was the data we found, I might want to know, hey, did more of my students complete the laps in 16 minutes or more, or in 15 and a half minutes or fewer? Look at it. All you got to do is count some dots, right? When you think you know the answer, give me a thumbs up. Charlie's got it. Good job, Charlie. Be ready to explain. Robert's got it. Max has got it. Elena's got it. You're counting your dots. Which side has more? Katie, what are you thinking?
The left side has more.
So the left side has more? So is that 15 and a half minutes or fewer, or 16 minutes or more? Which one is that? The left side.
15 and a half.
Very good. Did you count up all the dots?
Yeah.
What did you get?
I didn't count up the dots. I just forgot for a second.
Oh, that's okay. So you just looked
I
at
saw
it.
that more dots were bigger on that side than on the other side.
That works. That's fine. You could do it that way. So your answer is 15 minutes or viewer. That would make me happy if I were the coach of that team or of that class, because that means that they're running pretty fast, most of them. So if I wanted to count to double check my answer, Katie, I would just say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 people on this side. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Only 11 people took longer than, or had 16 minutes or longer. Okay, nicely done. That is all we are going to be doing today for problem solving, because I wanted to make sure to do a little bit of review with our multiplication and division facts. So we are going to need our math spirals. In case we don't know one of the answers in our GimKit, we can draw a picture. So we're going to do that. Before, how are you feeling about problem solving? How'd we do? Neat, neat, neat. Problem solving using line plots and bar graphs. Remember, read carefully, reflect. Okay. So we are going to go to gimkit.com/play, and you're going to enter the code that I give you. Now, I want to make sure you realize where the link is. The link.
Robin, can I quickly say, some of the kids are asking me if they can not play, and no, it's part of your assignment. It's part of the work here that we're doing. You need to play.
Thank you, Mrs. Harrison. And you can probably stop recording now.
Oh, you bet.
We are going to